Welcome to part two of refactoring the agent manager system. There's two important files. One is agent manager. This is responsible for launching new agents. And agent manager is a piece of code that's on every single client. But if every single client was simultaneously creating their own agents, you'd have way too many enemy agents. And so I've made a change to make a variable that is instantiated and just attached to the window. This is just for debugging reasons, but you can just export um, this thing. And it is just an object, and it contains that the leader is false. And what this will allow us to do is that we can just import this anywhere, and because it's already instantiated, it's going to have a value. And if you change that value anywhere, we'll know that the value's changed. So in Scene Manager, we're listening to like new leader, and this message will change leader to true if the announced leader is yourself, the member ID matches. And then in Agent Manager, which is also instantiated in Scene Manager when the scene is created, Agent Manager will essentially perform these two functions, which is to create new agents when you receive an agent message. So all clients receive this, including ourselves. Even as the leader, we listen to that. This creates new agents. And when you come into the scene, there might already be agents in memory, and this will create those agents. So both of these just create agents. In addition to that, we have this constant loop, which is basically a no-op if you're not the leader. So this calls update. And because you can become a leader at any time, this will just check every, maybe this is too frequently, let's check every second or so to see if we become the leader. And if you become the leader, then you'll perform some kind of logic to send everybody else and yourself a new message, which is the create agent event. And currently this logic is not complete, but it says if the number of agents is less than the number of members and a wave number, for example, we want way more agents as the waves increase, right? Wave 1, wave 2, but right now there's no way to take a break. So as soon as it detects this and it's on the leader, it's running every second. When you kill, let's say there's 3 people, you're going to have 3 agents on wave number 1. If you kill the 3 of them, in 1 second, those 3 will pop up again because, oh, actually, it'll just create 1. So this will just create 1. So we kind of want to create this with some proportion to the wave number. So this isn't complete, but this is running on the leader. It'll create agents. And then all the other logic for how the agents move is pushed to an agent class. So this create agent event emits this and then is listened to somewhere else. So agent spawned happens in agent.ts. Now what this thing does is it just takes a name and a position. So it receives this message type here, which is agent spawned. And unlike entities, we don't really need an ID. We're not keeping it in the database. So we only temporarily need it in memory on the gen server. So we just have agent spawned, agent directed when you're moving it, and agent hit. So agent also responds to whether something is a leader or not. First, when the constructor will create the body, and then on some set interval, we are sending ourselves a message. So we have this message bus, and the reason why I'm using this is I want a single place where the code is executing more or less in a loop. So I'm using an RxJS subject because then I can just subscribe to it, and it's not exactly blocking because it can be an asynchronous function, but it's processing in one place, and I can put a lock on it, for example. So I have this lock here, which is it's unlocked by false, and every second it will just send our behavior subject a message if it is leader. Now, if it's not the leader, it won't do anything. But because you can become a leader at any time, we're listening for it. And that goes into the bus and it says, hey, maybe you want to update your position. So go do something, update. That'll send ourselves and everybody else a message. And so we need to respond to that. So here's the receive the member movement, and then we're listening to the signal hub for agent directed. And if the name matches our own name, then we'll pipe it into that event bus because, again, we want to process updates. And so we're kind of mimicking what Elixir Gen Servers does. We're processing messages in order in an event loop. I'll make this comment. That's the second thing it does. So it receives messages, and it will periodically send itself messages to wake itself up. And let's see, it will, and this starts the event loop. So this is the kind of bread and butter of the piece. It will subscribe to its event loop, listening for the event. Now, if the event is a simple update, get out of here if you're not the leader. It's not for you. This is just another sanity check here. Get out of here if we're locked. So let's reverse it this way. So if you're not the leader or this is locked, if this is locked or you're not the leader, just return. Okay. Otherwise, you're not locked here. Set the lock. And then find a random point around you that's on the floor. And if you can find a random point, then go ahead and emit an event for everyone else and ourselves, and we'll start moving there. Otherwise, you couldn't find a point, just say that the lock is false. You'll try again later. Random point or null will try 10 times, and it will just randomly look for points around you, and then see if those points around you on the ground are in fact touching the ground. So here's some. It'll return on the first point it finds, and this checking if something's on the ground will just raise this point about head height, then cast a ray down into the floor. And if it intersects the floor at a position that's within, you can have a little bit of bumpiness, within 30 centimeters of the current transform floor position, then hey, yeah, that point's on the ground. Let's go ahead and go there. So maybe we wanted to do this a different way, which is to calculate not different random points on the ground, but maybe different directions with kind of a different frequency. So let me have an idea. How about let's say degrees is, let's see, return -5 degrees or +5 degrees or 10 degrees. or 15 degrees, 20 degrees, 30 degrees, 35, 40, 45. So this is how many degrees you'll test. So these are uh, most frequent degrees. So we'll say these. And in fact, I think we can double this into the negative side. Copy and paste these, and we'll just put a negative symbol in front of these. No problem. Okay. And then you have some less popular degrees, which is off to the side. So 45 degrees, maybe 60 and negative 60. So you can spread them, or this may be enough. Like you never totally turn around, just kind of angle this way. So maybe actually the most frequent degrees are 5, 10, 15, 20, 30. These are more frequent, and less frequent degrees are 45 and 60 degrees, 90 degrees. And then you almost never turn around entirely to go behind you. So I want to draw from an angle here that's maybe twice as likely to draw from these as it is these. So let's see. We can say radian samples is an array, and we'll loop through this twice. Maybe these are just samples, or yeah, samples. And then for most frequent degrees for each frequent degree here, we'll just say samples push frequent degree. So you get in there one time, but we'll also push the negation. And we'll do it twice. So you have these in there. And then we'll just do it once for the less frequent degrees. So less frequent degrees for each less frequent degree. We'll just say samples dot push the less frequent degree and the negation of it. And so now if we randomly draw from samples, it should be twice as likely to draw from this or negative this than it is from these, which should happen half as frequently. And so we can return samples. And to avoid this computation, maybe we can just maybe copy it. Or let's see, what's another way we can do this? We'll just cache it. We'll cache it during construction. Public degree samples. Is an array of number. And then you'll just say this degree samples is this degrees. Okay, so that'll do that. And we can say get random degree will be this degree samples. Select one of these, which will be the same as the way we select random agent. Random, there we go. This function should work. So a random degree would be math random multiplied by the length of degree samples, length, and floor. So you get a random degree here. So instead of picking a point randomly around, which we don't really know how far to go, we'll pick a random degree. And then we'll cast a ray between ourselves and that degree and check if that space is on the floor. So let's say random point or null. Instead of doing this, we need to find our forward angle and then change that by a degree. So how do I draw a line between my forward position and an angle? So what I could do is I could just turn the angle and then cast it from this to that other position. Pause for a second. So I have an idea. We have this ray that we've created in the constructor of the body. And it's just a array that's got some value, but you can override its origin and direction. So in this find random point area, you can override this ray, say that the origin is this transform position, so it's on the floor, and the direction is this transform forward. Okay, so we have this beam that's on the floor. Now, we want to rotate it. Can I rotate just the ray? You can say ray transform. Wait, can I? Babylon JS array methods transform. Okay, Babylon JS Babylon array. Okay, so transform. Transforms the array, and here's the matrix. And I've never tried this before, but we can try let matrix equals Babylon matrix identity, and then matrix dot rotate. How about Babylon matrix rotate in Y, and the angle, let's try 45 degrees. Babylon degrees or angle from degrees 45 and radians. This gives you a new matrix, so matrix equals that, and I've got to take a previous, wait, creates a new, I guess this is just that. We don't need this, right? What's this? Oh, gotta do that. Okay, so that might transform it. In order to see this, I need to see this in isolation. Let's just comment some things out so it doesn't move. So let's comment out the set interval business. So we're not going to move it at all. This is just receiving and start the event loop. Okay, it doesn't do anything. And then I'm going to draw, it's going to draw my beam in the create body part. Let's go to the create body. It's drawing this from here forward. Okay, there's the ray. Okay, so it's going to draw it. We're showing that. And then it's not going to do anything. And then we can call a function to see if we can rotate it. Let's just make a function. Let's do cut this, and we'll say rotate ray. And then we'll just say this direction is going to transform from the position that you're in and forward, and then we're going to rotate it, and that's it. Okay, so if we go to our, we haven't started the server yet. Let's start the server. Jump in here, and bam. Okay, we have a beam there, right there on the floor here. And what is this red stuff here? Anyway, don't get distracted. Now let's grab the agent. So it's going to be scene manager, agent manager, get random agent because there's only one, and rotate ray. Rotate ray. Didn't do anything. Undefined. Transforms a ray by the matrix. Returns a new resulting ray. Okay, so let's say this ray equals that. Didn't do anything. What if we just made this instead of forward, it's the backward, or I don't know. Console log ray origin and ray direction. This ray origin, this ray direction, and then let's log this again after we've multiplied this by the matrix. And let's also get the matrix. Console log matrix. Okay, so originally this point is 0, 0, 0, so 1 in the z direction, and then this is the, what is this? Oh, that's the matrix. Gigantic thing, isn't it? Yeah. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. That seems about right. Okay, and then final point is, yeah, something did move. You get a ray is here and here. That's your direction. Yeah, that seems like it will work. I think it just, what, it didn't draw or something? What is this ray value now? Yeah. Oh, maybe we have to tell the helper? Oh, I wouldn't think we need to. we have to refresh it. Babylon.js refresh ray after transform. Or even if you don't, you can just copy the direction. Direction copy from. Yeah, totally worked. Okay, so 2 meters, that's the point I want to go to. Is it on the floor? If we stick a point straight down, so I think we should stick it a little bit further, make it well, if you made it too much further, then it wouldn't attempt to go to any points that are uh, well, okay, this is just checking to see if there's a floor there. So we could check it a little bit farther. We'll go there if there's a floor. We set it 5 meters, and if there's something in front, okay, so this will just get a random ray. All right, let me write down what I'm trying to do. Here's the logic here. Okay, so clear some space. Get a random ray in random direction of the agent. Set the ray length about 5 meters. Cast another ray downward to see if intersects floor. If there is floor, move to that point. Then on each frame, check if mesh intersects short ray. This can be maybe 2 meters. This is a short forward ray. And if so, cancel current movement and animation and pick a new random point And it can't be the same as the first. Can't be same degree as the last one. So it needs a little bit of memory. Okay, so let's take a break, but this is kind of the design that I'm thinking about.